I built the simplest gate that I could come up with, and it looks like this. So this is a wire fence, and that means that the gate can be really light. I don't need a heavy-duty frame. I can use this lightweight lumber, and that allows me to keep it simple, use simple tools. I don't need any fancy joinery. I have another gate that has some nicer joinery. It's a much bigger gate, and I'll drop a link to that one in the description. But this one, I try to keep as simple as possible. This is 2x2 pressure-treated lumber. The corners are joined with steel brackets, and then there's also dowels inside the joint, which are totally optional. You can do it if you want, and I'll show you how, but you could skip it as well. This is 30 inches, and it's big enough for a person, obviously, to fit through, big enough for a lawnmower to fit through. There's no digging required, because I use these giant spikes. For materials, I'm using a pair of 4x4-inch severe weather-treated posts. These are 6 feet long. I'm also using a pair of 2x2-inch pressure-treated lumber. These are 8 feet long. And then I needed a little bit more, so I grabbed a scrap piece of pressure-treated lumber. I'm using 4-foot-tall welded wire fence, also known as garden wire. You can use chicken wire. Any of the wire fences, as long as they're roughly 4 feet, will work for this gate. For hardware, I've got 1¼ inch by 1/4 inch oak dowels, and these are optional. I've also got 1¼ inch enamel screws that are exterior rated. I've got these 5-inch corner brackets. They're steel with an enamel coating so that they're exterior rated as well. I've got 4 of those. Then I've got these 3/4 inch staples. They're called poultry net staples. They're basically galvanized, and they'll be used to attach the fence to the gate. Here I've got these 2-inch galvanized lag screws. I've got 8 of them. Titebond 3 exterior wood glue and an applicator. For the latch, I'm using a very standard zinc-plated hook and lever kind of latch. Very standard. There's a lot of different versions of latches that you can see what works best for you. Now the hinges, this is very important. These are 4-inch hinges. They're narrow so that they'll work well with the 2x2-inch lumber that we're using for the gate frame, and I'll drop a link to all this stuff in the description. I also use these 6D galvanized nails. I use 2-inch, but you could use 2.5 or even 3-inch nails. And then anchoring this entire project are these Simpson Strong Tie Easy Spikes. They're 3 feet long. I got them at Lowe's. They're more expensive than all the other components combined, but if you don't want to dig, you're going to need these guys. I have 2 of them. This is the bottom piece of the gate frame, and I'm measuring this 30 inches. That means that the gate will be 30 inches wide, and we'll leave a 1/2 inch gap on either side, so the gate opening will be 31 inches wide. I got the first piece to length, and then I matched it up with what will be the top piece of the frame so that these are perfectly matched pairs, and then I cut the top piece to length. Next, I cut the side pieces 45 inches tall, which means when we add the top and bottom piece of the frame, the total gate height will be exactly 48 inches. And it's worth noting that you might want to go a little bit taller than that because the wire fence is also exactly 48 inches, and you might want some margin for tacking it in on the top and bottom. So you could go a total of 50 inches. That'll give you a nice little bit of extra meat for tacking it in, which you'll see here in a second. I chose to go exactly 48 inches high and let the wire protrude a little bit at the bottom. Here I've got what's going to be the side of my gate, and here I've got the bottom. And of course I'll be putting these together at a nice 90-degree angle, and I'll connect them using these right angle steel brackets, just like that. But before I do that, I want to make sure I get a nice tight seal where these 2 pieces of wood come together. Over time, what I don't want to happen is for any gap to form. It's unlikely because these steel brackets are pretty strong, but it is possible for them to bend, especially if somebody puts a lot of weight on the top of the gate, if they grab it to open it. I have an opportunity now to seal this off, so I'm going to take advantage of it. And of course, I'm going to do that using some exterior wood glue. And there's a couple different ways that I can make this joint. And the fastest way is just to take a 3-inch exterior wood screw, which is not what this is. This is an interior wood screw, but it works for demonstration purposes. And to just run it right up in between the two, cinch these two together with some glue in between, drilling a pilot hole first. And to do that, I take a drill bit that's about the width of my screw minus the teeth. And I use that to drill a pilot hole 3 inches up inside, and then I run this in, and that will hopefully prevent any wood from splitting. And that would be the fastest and simplest way, and definitely an acceptable way to make all 4 of your joints. But I'm going to do something that's just a little bit more sophisticated, and that's using dowels. I figured this would happen. So the reason why dowels are advantageous is they prevent any wood from splitting even just a little bit, and that's important when we're working with smaller stock like this on exterior projects that could degrade over time. They also create a really nice clean connection. There are no screw heads protruding anywhere here. Of course, you could countersink your screw heads, but this eliminates that need entirely. They are a little tricky to make. The simplest way is to do a single dowel connection, and to do that by putting an X on the end of the piece that you want to connect, drilling a hole in the center, putting that up against the right angle connection you want to make, and then trace that connection, make another X, put a hole in the center of that X, a single dowel between them, you've got your connection. Of course, I have gone a slightly different direction. I've done 2 dowels at a diagonal. That just doubles the bonding strength, essentially. And the only way that I could think of to do this consistently and accurately is to use that hinge as a template. There are no fancy doweling jigs involved in this. I'm not sure that that would even help anyway, but I used the hinge as a template, and I'll show you how to do that. Regardless of the direction you choose to go here, I definitely recommend getting some scrap pieces and practicing before you do this on those frame pieces that you just cut. Now, if you want to do this method, you have to use these exact hinges. I'll put a link to them in the description. It just so happens that the holes on this hinge line up perfectly with the space I have to work with on these 2 by 2 inch pieces, which of course are not a full 2 by 2 inches. I'm picking the 2 holes that I want to use, and I'm basically just letting the top half of the hinge be my stop, collapsing it at a 90-degree angle, and then clamping it down to the workpiece using the edge of my workbench. I used a nail to mark the center of the holes, and then I drilled about 5/8 of an inch deep using a 1/4 inch drill bit. It's important here to get most of the sawdust out of these holes, otherwise the dowels will not seat properly. Right, now this is the important part, because when I'm making this transfer, this is going to be the bottom piece. I'm transferring it directly to wherever it's going to get drilled. Flop the top over, and then you can flip this around. Line that up with the side. This transfer is really important to make sure you get the holes lined up properly. It's very easy to get it backward, and then the holes will be diagonal from each other, and so I recommend testing it on a couple scrap pieces before you drill your final frame. Here I'm just dry fitting the dowels and making sure everything lines up before my final glue up. And once I made sure everything was aligned, I put glue in all 4 holes and then a little bit on the mating surface, and then I put the dowels back in and put everything together permanently. Once everything was tight, I used a corner brace to make sure everything was nice and square, and then I moved on to the next set of joints. I mocked everything up, and I drew these lines to mark where the pieces should connect before I drilled any more holes. And then for some reason I flipped the frame over to drill the remaining holes, so the lines disappeared from this shot, but I'll flip it over again and you'll see them before everything is finalized. And finally, I checked all the corners with a square to make sure they were nice and tidy before gluing everything together. Now it's very hard to find pressure-treated lumber that's perfectly straight, so I clamped everything to a flat surface and let the glue dry overnight. Of course, that meant I had to pry some pieces off the next day and scrape off some crap, but the frame was nice and square. If your frame overlaps just a little bit at the corners like mine did, you can use a flush cut pull saw and trim off the excess. Then I highly recommend, regardless of whether you have that overlap, you take some sandpaper and just round off those edges just so nobody catches a hand or a foot on them. Now for the corner brackets, I clamped the frame to the table again, and I put washers underneath the corner brackets just to lift them up off the table a little bit so I could get my drill down there and make sure that those screws were going perfectly perpendicular to the wood as opposed to kind of at an angle. And these are those 1 1/4 inch exterior wood screws. They've got a nice gray enamel on them, and they should hold up really well. For additional support on the frame, I'm making a mark at 16 and 32 inches, and these are going to be for horizontal supports that not only help just kind of solidify that frame, but also give us something to nail that wire mesh into. The interior of our frame should be right around 27 inches wide, and that's the length we're going to make these cross supports. We want these nice and snug, so a rule of thumb I like to follow is to cut them just a little bit long and then kind of creep up on that final measurement, test fitting until they're nice and snug. Now I've got my frame clamped to the work table again. I've checked for square on all those cross supports, and I'm nailing them in using those 2-inch galvanized exterior nails. And of course, like I said, you can use 2.5 inch, 3 inch, whatever's not going to split your wood but still give you plenty of support. Here's a badly shot visual of the entire frame complete. You can't see everything, but I think you get the idea. And those nails are not where anybody should be really touching them, but they are nice and smooth to the touch just in case, a little shaver gets their hands on them. If your pressure-treated lumber has any gnarly spots like this big ugly knot, that is a place where it can still be vulnerable to the elements. So I took a Dremel with a little routing tool and just went in and cleaned this thing out. And I patched it with some wood filler. And this is a product I like a lot. It's an epoxy-based product. It's 2 parts a substrate with a hardening compound. You basically mix them together, and then you have about 3 to 5 minutes to basically do whatever you need to do before it starts turning into plastic. If you're using a welded wire fence material, this is where it's really important to get your cross braces at exactly 16 and 32 inches on center so that you can tack your fence material into the middle of those braces. If you're using something like chicken wire, that's not really as important, but regardless, this is also where the height of your gate comes into play. If you remember, I said you might want to make it a little bit more than 48 inches tall, and that's because the top and bottom, if your gate is exactly 48 inches tall, the top and bottom of your fence will be tacked into the very edge, and you kind of want them tacked into the center of the frame. I'm allowing mine to overlap a little bit extra at the bottom so it can sweep through the snow without hitting any resistance. These are those galvanized poultry net staples, and I like to use a pair of pliers to tack them into place so I don't smash any of my fingers. I also like to start in the center of the fence material and kind of work my way out. And I like to tack them in place at an intersection of 2 of the wires so I get both horizontal and vertical stability. There are a couple ways to finish off the sides of this gate after I cut off the wire fence. Here I'm using a putty knife and I'm sticking it underneath the wire so that when I use the grinder wheel, it doesn't damage the wood too much. This worked okay, and there were some spots where I couldn't quite get it. But the first method to finish off the side is to cut all these side pieces off short, and then I'm going to smash them into the wood so that they're not sticking out and they won't catch anybody's hand or finger. So I'm going to use either a nail set, or if you have a chisel or something, blunt and strong. Basically, I'm just going to take this and put it on the very tip of that wire and smash it into the wood. And this pine is soft enough that you can slam the stabby end of the wire down into it, and it'll be pretty safe, but there is a method that I like a little bit better than that. So on the other side, I'm cutting off the wire a little bit longer than I did on the first side. This is about 1 inch to 2 inches beyond the last contact point, and I'm going to file off the ends so that there's no burrs or jagged points sticking out, and then I'm going to bend these back on themselves into a nice little loop. For the posts that are going to go at either side of the gate, these are going to sit flush with the ground once they're inside the little spike collars, and that means you only need to leave a couple inches of space at the top and at the bottom just for some wiggle room. I think I cut these to about 55 inches tall. And this extra cutoff piece I'll use to drive the spikes into the ground. Driving in the spikes that support these posts is one of the trickier parts of this entire build. And this, of course, is not a spike. This is a U-post that I'm driving in to serve as kind of like a visual guide, because the spikes have to be plumb both side to side and front to back. So I'm hoping that this U-post, if it's plumb front to back, can just serve as a visual guide, and I'll only have to worry about the side to side part as I drive in the spike. It turns out that using that U-post as a reference, and even my level clamp method here, turned out to be kind of unnecessary. On the second spike, I just checked it every couple of strikes side to side and front to back, and that was just as simple. After I had both spikes in, I put a post across the back, and this kind of revealed that they weren't exactly square with each other. You can see there's a little bit of a gap here. And while I could have left it like this, and it's certainly fine because the gate will still work, I wanted to show that these spikes are pretty easy to take out of the ground. And of course, this is all assuming that you don't have any big rocks or roots in the area where you're trying to put your spikes. To find the location for the second spike, I measured 30 inches from the side of the first spike, plus 1 inch for a little gap on either side of the gate, plus another 2 inches to the center of the second spike, and I marked that with this little oversized nail spike thing that I don't know where I even got it. And this is a little tip: if you can't follow all those measurements that I just kind of spewed out at you, you can put the spikes upside down and then dry fit your gate just to get an idea of exactly how much space you're going to have on either side. I went with a 1/2 inch. I probably would not recommend these spikes if your gate is at all heavy. My gate is extremely lightweight, so I don't ever have to worry about it sagging or leaning. Also, the ground in my part of the country is pretty soft during the winter months, which is when I installed this, so the spikes went in really easy. But if your gate is heavy, you might worry about it leaning over time with these spikes. I made sure these spikes were seated nice and flush with the ground, and then I measured to see if they were level from one to the other. They were off by maybe about 1 inch or 2, which is really not a problem. They don't have to be exact in order for your gate to work effectively. One of the posts took a little coaxing to get it fully seated. I used a sacrificial board on the top so I wouldn't mess it up with my sledgehammer. I recommend you give them both a couple taps just to avoid settling over time. In the corner of the spike bracket, where there's a little gap, you'll see 4 holes, and that's where I drilled 1/4 inch pilot holes and then attached the exterior galvanized lag screws. Attaching all the screws in one corner may seem a bit odd and unbalanced, but it works, and it also just kind of tightens that bracket like a collar around the post, kind of like a big hug. And you don't have to do this, but whenever I'm working with large hardware and soft wood, I always like to snug up the bolts by hand. Here I'm using 1/4 inch strips of plywood that I had cut off camera, and I'm going to use those as spacers between the gate and the post so that I can clamp it directly to the post for the hinge attachment. This is going to be the hinge side. I'm leaving a little less gap on the hinge side and a little more gap on the latch side. Here you can see how the hinge aligns, and it's at a bit of an angle, but the hinge pin is centered directly over the gap. And this is also why it's really important to use this specific hinge, because any other type of hinge with these 2x2 pieces of lumber is going to be too wide. The lower hinge has to attach to a cross brace because that spike collar is directly in the way of the lower part of the gate frame. The latch is pretty self-explanatory. Just make sure that when you're setting it up, you put the tab toggle part thingy at the top. The last thing I did was to make some caps for the top of those posts because they get a lot of weather and that's end grain, so they just have a tendency to crack over time. And so I took some 4-inch appearance board that was pressure treated, cut them down into 4x4-inch squares, and then I ran them through the table saw at a 45-degree angle to make a nice little bevel. And then the caps turned out like this. Of course, there are 4 of them because I made 2 gates at the same time and the other one's in a different video. And then to install them, I just used the dowel method again, where I just struck a line from corner to corner across the top of the post. And then I used a 1/4-inch drill bit and drilled 2 holes along that line about 5/8 of an inch deep. And then I used these doweling centers or doweling pins, which you can get in a doweling kit, really cheap. I think this one was about $10. And I put the cap on top just to dry fit it, and then I used a sacrificial board. Just gave it a few taps just to make a little impression on the underside of that cap, as you can see. And then I drilled the cap the same way that I had the top of the post. This one I didn't even bother to glue in place because if it gets gnarly someday, I'll just take it off and replace it with a new one. One thing I wish I had done differently was to rotate this spike 90 degrees because the clearance on that lag screw is pretty tight, but it still works. And that just about shuts the door on this project. I hope you found that build easy. If you could think of a way to do any of that easier, please comment. I tried to do this in the spirit of the rest of this fence, which like I said, was really easy to install. Thanks for watching, and if you try to take this on, please let me know how it goes. I hope that it's as easy as I intended it to be, or at least as successful in the end.